Welcome back, statistics students. Lesson 9, part I. We're getting there. Looking at residuals. They're very important. If we're evaluating the quality of our model, it all comes from the residuals. Previous video, we learned about what to look for. We're looking for equal spread as we move left to right across the page. We're looking for no pattern in that residual plot, and we're trying to identify any outliers or unusual features. A couple of examples here in video I. We can go back to that neighborhood data set. We were using the size of a house, square footage, to try to predict its assessed value for tax purposes. Okay? Comment below on the conditions needed to proceed with a linear regression analysis. I can see in your notes you've got both the scatter plot and the residual plot. Here's the scatter plot. On the x-axis is the x variable, the explanatory variable, which was square footage, size of the house. Up on the y-axis is the assessed value. What are we looking for in this picture, the original scatter plot? Number one, is the form of the relationship linear? And it sure is. If you just look, it's an eye test. Looks linear. I can begin to see, do I have about the same amount of spread about the regression line? Okay, and it doesn't look like we have too many problems with that. I can look at that on the scatter plot. Here's what I'm looking for. And then finally, are there any unusual features? Any houses maybe that were very small but assessed for, say, $300,000, or were very large and assessed for maybe $200,000. Everything here seems to sort of follow the general path. There are a few big residuals. If we look at this house right here, I mean, that one's sort of far from the beaten path. So is this one, and even perhaps, those are the three with the biggest residuals. Okay. When we go to a residual plot, essentially what you're doing is you're taking the scatter plot and sort of turning that regression line horizontal. And so we'll put the residuals here on the y-axis. Let's take a look. All right. Next on the right there, same page, residual plot. On the y-axis of residuals, you can draw a line at 0. And that line at 0 is the mean residual. Some of the points are above the regression line, some of the points are below, and if you average them out, you'll always average to 0. So we can see that there's no points exactly on a line, but those would be the points on the regression line with a 0 residual. Okay, what are we looking for here? We're looking for no pattern. Okay, in the original scatter plot, we want to see that linear pattern. But when we move to the residual plot, we want to see no pattern, random scatter, and I think we're safe. Okay? Equal spread doesn't seem to be too much of a problem. If I just put some squiggly lines in here, there's about the same amount of spread left to right. And we have our three houses, which big negative residual and two big positive residuals. Okay, so it's the two at the top and the one at the bottom. I'm not going to let that dissuade me from meeting the equal spread condition. I think we're good there. There doesn't seem to be any fanning or anything like that where the residuals are very small for the small houses and very big for the large houses. But what I would do if I was completing this analysis for real, I would check, were these typos? Are these special houses in a certain part of the neighborhood that might be in a different location? Do they belong with this group? All these houses came from one neighborhood in Elkton. Okay, so probably some space to write if I do, or not. All right, well, we can squeeze this here if I get this out of the way. Looking for three things, students. Let's write them down. I'm just going to write right over this here. Linear, question mark. Is a linear model a good choice? All the clues are telling us yes. Yes, a good choice. Scatter plot looked linear, no pattern in the residuals, so we're good with linear. Number two, equal spread. Question mark. As I move left to right across the page on the residual plot, do I have equal spread? Nothing is really screaming that we don't. So equal spread, this looks like it's good. Looks good. So the first two conditions are met. Number 3, any unusual features, any outliers. I think there's 3 that we should take a look at, right? So down here, any unusual features. Probably 3 houses need to take a closer look. Okay, we've identified them. Use the 2 scatter plots in conjunction with each other. They're essentially telling you the same thing. The residual plot is just take your regression equation, sort of even it out at a horizontal line of 0. Okay? Now, one thing I want to say before we move on. Just because these 3 houses have large residuals does not mean we need to start cherry-picking data points out of our data set. The goal is not to remove data points until you've got this nice, perfect-looking linear regression line on a beautiful scatter plot. Okay? I would investigate, were they typos? Okay, they weren't. Were they part of a different part of the neighborhood, or was this a new development, or houses with huge additions on them? If I find some clue that tells me that they may not be like all the other houses, then I could justify possibly removing 1, 2, or all 3 of them. But you've got to have a reason. The reason cannot be make the scatter plot look better. Okay? If there's lots of variation in your data, then that sort of is what it is. We have to use what the data is telling us. All right. So we looked at the conditions on this neighborhood example. I think there's 2 more if you flip the page. So let me get this erased and take a look here. New example, let's look at fitting a linear regression equation to the mold colonies data set. So here's how this one goes. We'd like to predict mold count, how many mold cells, or however it's measured, based on the hours of time passed. So we have a petri dish in a laboratory and a mold culture, and we're sort of looking at its size or doing a count. As time passes, this mold colony increases in size. Comment below on the conditions needed to proceed with a linear regression analysis. We had to put one in the notes that was a clear-cut, not linear. Here's ours. As I progress in time, as ours gets bigger, you can see the mold count in your notes increasing, and all of a sudden it just sort of blasts off, right? Increasing at a slow rate, and then all of a sudden the rate of increase is increasing. We would not want to use a linear model to model this phenomenon here. Okay, so this straight line, this is a linear model. Okay, but the data is not linear. Once we see such a clear-cut picture of nonlinear data, we don't proceed with the regression tools that we know, these linear regression tools. We stop. Okay? It's not the right fit for what the data is telling us. Okay? There are exponential models to model exponential growth. We'll touch upon them in lesson 11, I believe, or lesson 10. But for now, this would be stop the presses. We do not proceed. Check out that residual plot. If I take this regression line and turn it horizontal, and now I'm looking at the residuals of the data points, look what we get. We get this huge parabola. I'm just going to sort of do this so you can see it better in the video. Okay, erase this linear model. And here's an easy question, but do you see a pattern? Remember, this is a residual plot. If linear is a good choice, you should see no pattern in the residual plot. Linear is not a good choice, and look at the pattern. Now we picked this specifically to show you, okay, there's a clear-cut pattern in the residual plot. So, of course, just to repeat, linear is not a good model. We really didn't need to look at the residual plot to come to this conclusion, but it reinforces what we see on the scatter plot. All right, back to your favorite example. I think it's direct loans at the bottom, and then we'll move on. Last one, students. Look at the scatter plot, direct loans. Probably getting sick of this example, but it's a good one. We can understand what's going on. Number of loans on X, loan value on Y, comment on the conditions. Okay. Number one, looking at the scatter plot, is linear a good choice? You betcha, right? There's no curves to the data points. Straight line looks like it fits just fine. Number two, do I have about the same amount of spread throughout the whole X range? Most of the small schools are very close to this regression line. Once I get to the larger schools, we start getting a bit more variation. Okay, so that might be an issue. We can begin to detect it here on the direct loans. And we've said it before, but maybe we shouldn't be lumping together University of Texas, West Virginia University with places like Cecil College. I mean, we have 178 loans. They're granting 12,000, possibly different populations, separate analyses. All right. I've got some unusual features. Maybe these gigantic schools, the data points are sort of far away from the cluster of points, but they do follow the pattern, right? We've got that strong positive pattern. The more loans a school grants, obviously the larger the loan value. Okay. Take a look at the residual plot to wrap this up. On a residual plot, you can always put that straight line at 0. That's the mean residual. The one thing that's catching my eye is I've got, maybe not necessarily the last two, but the spread for my small schools is sort of small. When I get to these big schools, I have lots of variation. So might be some problems. Those outliers need a closer look. Number one. Number two, the equal spread condition. Is not met. Okay, and we had a fix. A few videos ago, we split two separate analyses. Do a regression for the small schools, do a separate regression for the medium or large schools, and these problems will be fixed and the predictive value of the models tends to go up as well. Okay, a lot of these scatter plots and residual plots, it's more subjective. One student might look at a scatter plot, come to different conclusions from the neighboring student. So we encourage you to be able to verbalize what you're seeing and just back it up. If you feel there's a curve and it's not linear, then say it and be able to back it up. And as instructors, we'll go with you as long as you can speak clearly and make sure that what you're saying is in the ballpark. Okay, so we've got one last topic in regression. It's R squared. It's a tricky one, so hang in there, and we will see you in class.